Okay, so here is example 3, and I need to find my reactions. At A, I note that I'm fixed, and at B, I have a roller, and then I have this internal pin at C. So I know if I have fixed, that's 3 unknowns, plus I have a roller, which is 1, so I have 4 unknowns. And I only have 3 equations of equilibrium, which leaves me 1. So it's 1 degree. I need to find something else to help me come up with the equilibrium equation. And this is where that internal pin at C gives me that additional equation. So now we have 0. We can actually solve this problem. So the first thing I'm going to do is let's just draw an overall diagram, an overall free body diagram, and see where that leads us. So at A, I have AX, AY, a moment at A. And over here at B, I have BY, an applied moment of 2,800 pound-feet. These are not actually loaded right at the centroid of the beam, which is where they ought to be loaded, but we're just going to assume that they are and not worry about the depth of this beam. So I'm going to go ahead and break this down, and I have 800 times 12 over 13, and going to the left, so I have an 800 times 5 over 13. When I look here, I'm going to have 300 sine 60, and to the right, 300 cosine 60. So we also know that this is 4 feet, 4 feet, 8 feet, and 4 feet. So when I'm looking at the overall, it doesn't matter that I have that internal pin at C because it's internal and we haven't actually taken this apart. We just look at the overall outside, if you will, applied forces and external reactions. And so this is where I can see I have 1, 2, 3, 4 unknowns. If I tried to sum moments at A to get rid of AY and AX to solve for BY, because it's fixed, I would also have to include this unknown moment at A. So by summing moments at A, you're going to have an unknown BY and an unknown MA. And that's just not going to work very well for us. So I have to isolate and look. If I look from A to C, okay, if I look from A to C, then at C I have a CX and a CY. I still have my 800 times 12 over 13. And I have my 800 times 5 over 13. And I have my unknown at the wall AX, AY, and moment at A. 4 feet, 4 feet. So when I look at this, I've got 1, 2, 3, 4, 5 unknowns. If I sum moments here, I have to include my unknown AY, my unknown moment. I only have 3 equations. So let's look at the right-hand side. I have this unknown BY. I have 2,800 pound-feet applied. I have 300 sine 60, 300 cosine 60, equal and opposite, equal and opposite. Okay, equal and opposite, equal and opposite. When I look over here, I have 1, 2, 3, 3 unknowns, 3 unknowns. So we're going to call this our overall. We're going to call this one our free body diagram AC. We're going to call this one our free body diagram CB so that we can keep our equations organized. So I'm going to start with my free body diagram of C to B. And I need this reaction. So I'm going to start with summing the moments about C equals 0. And when I do that, I get negative 300 sine 60. And let's look at this is 8 feet and 4 feet. So times 8. The x component goes straight through because we're assuming it at the centroid, minus 2,800 pound-feet plus by times 12 equals 0. So let's get our calculator out. 300 negative 60 sine times 8 times 2800 negative, whoops, I don't know what I did there. 360 sine times 8 times, and then 2800 plus. We're going to take those over to the other side using algebra, divide by 12, and I get that by is a positive 406.5 pounds. Positive means my up direction was assumed correctly. And here's where I have a lot of options. I can go back on my overall and list that, and when I do, the only things I have unknown are over here at the wall, 1, 2, 3 unknowns, okay? Or I can use this little tiny piece, calculate CY and CX, and then transfer them through so that I'd have a smaller piece over here when I'm finding A. And either way is appropriate. You should get the same answer both ways. So my recommendation is, while you're learning, work it 2 different ways and make sure that you get the same answers. Okay, so let's just go ahead and continue looking at CB. And now we can sum forces in the y direction. And I have CY minus 300 sine 60 plus 406.5 pounds. And I get that CY equals, so I have 406.5, 360 sine times plus, but when I move it over, I get a negative 146.7. Okay, I'm not going to use arrows because what does up, what does down mean? Oh, this equals 0. What does that mean? Well, it depends on which side of the pen I'm looking at. So I did get a negative, and that tells me that I assumed it to be the wrong direction. And so I'm going to have to go back now and change the direction. I like to actually erase and change. Other people may not, but to me it makes more sense to just go ahead and fix my picture so that I understand what I'm looking at. So I have 146.7 and 146.7. Okay. And if we sum forces in the x direction, then I'm going to get a negative CX, because I assumed it going to the left on this side, plus 300 cosine 60 equals 0. So CX equals 360 cosine times 150 pounds. And it actually is going to the right, to the left as I assumed, which means if we're going to the left on this side, we are definitely going to the right on that side. When we put it together, equal and opposite, we get a 0. So when I go back to look at overall, I don't see that pin in my overall external force picture. Okay, so I can now move to my free body diagram, AC. And when I do that, the only 3 things I have unknown are at the wall. So I'm going to start with summing forces X. And I have AX minus 800 times 5 over 13 plus 150 equals 0. So remember, it was negative here because pulling to the left, equal and opposite pulling to the right. So we have 800 negative 5 times 13 divided by, add a positive 150, take it to the other side, and I get that AX equals 158 pounds, a positive value, so it is pushing to the right as I had assumed. Now we can sum our forces in the y direction. AY minus 800 times 12 over 13 plus 146.7 equals 0. So AY has to be, so let's do 800, 12 times 13 divided by, plus negative, take it to the other side using algebra, and I get 592 pounds going up, which is what I had assumed. Okay, and now I can sum those moments about A. It's fixed, so it does have a resisting moment. Okay, these are 0 minus 800 times 12 over 13 times 4 feet. Okay, plus 146.7 times 8 feet equals 0. So my moment at A, we get 800. 12 times 13 divided by 4 times 146.78 times, plus it's negative, but when I take it over I get a positive 1780 pound feet. Okay, and oh, it's in the direction I assumed, which is counterclockwise, so we're going to draw a counterclockwise arrow, and there we have our solutions. So how can I check to make sure this is correct? Okay, so I can say to check, use overall. Because I haven't used the overall free body diagram yet. And let's just sum forces in the x direction and see if they equal 0. So I had AX is 158, and then I have, okay, 800. 5 times 13 divided by, that's a negative value, okay? And then I have 300 cosine 60 times, that's a positive value. So I have, add those together, and I get 0.3, which in my book, because of rounding, 0 equals 0, check mark, smiley face. And now let's sum forces in the y direction. And you'll notice when I'm using this overall free body diagram, I'm not looking at the internal pins anymore, because 150, 150, they equal and opposite, they make a 0. So when I put this back together, that's why I don't see anything internal. Okay, so let's sum forces in the y direction. I have 592 for AY, and then I have 800 times 12 divided by 13, and then I have 300 sine 60 times, and then I have 406.5 from my BY, 1, 2, 3, 4, I only have 4 things, so add, 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 and again, I get 0 equals 0, check mark, smiley face. And now let's sum moments about A. It doesn't matter where we sum them, but we're going to sum it at A, looking at the whole picture. So if I'm at A, I have this resisting moment at A, so I have a 1780. Let's just get rid of it, 1780. We're going to come across, I have a negative 800 times 12 divided by 13 times 4. Come across, I have a 300 times sine 60, 8, 9, 10, 11, 12, 13, 14, 15, 16 times. I have a 2800 applied over here, which is negative, and then I have 406.5, which is BY, and it is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 times 20. Okay, and I'm going to add, 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 add. Hallelujah. 0 equals 0. Check mark, smiley face. So I can say with pretty good conscience and 100% like accuracy that I indeed found the correct reactions at A and B.